Hello my dear students, welcome back to our channel. In the last video, we discussed about inverse functions, how to find inverses, how to graph inverse of a function, relation between graph of a function and its inverse, and how to find inverse functions. Today we can discuss some problems related to that topic. Graphing of inverse function and how to find inverse functions. Okay, we can go to the video. For the previous videos, you can check the playlist or I will add the link in the description. If you are watching this channel for the first time, please subscribe. If you find this video useful, please like, share and comment. So the question, graphing inverse function. Each of exercise 1 to 4 shows the graph of a function y equal to f of x. Copy the graph and draw the line y equal to x. Then use the symmetry with respect to the line y equal to x to add the graph of f inverse to your sketch. Identify the domain and range of f inverse. Here graph of y equal to f of x is given. We have to draw the line y equal to x and also the function y equal to f inverse of x. Need not to find the formula for f inverse. Also we have to find domain and the range of f inverse. See the first question, y equal to 1 by x square plus 1, x greater than or equal to 0. Here the domain is x greater than or equal to 0. See the x-axis. Here x-axis, all the values from 0 to infinity. And here the range is, see, y-axis 0 to 1. So the domain and the range of f inverse just reversing. Domain of f is the range of f inverse and the range of f is the domain of f inverse. Okay, we can see that. Before that we can draw the line y equal to x. Here we can draw the line 1 1 and like that. This will be the line y equal to x. We know graph of f inverse is the symmetric to the line y equal to x. That is just a reflection of the graph f in the line y equal to x. If you place a mirror in this line y equal to x, you will get f inverse. Or we know input and output pair of function f reverses in the graph of f inverse. See here this point is 0 1 and here that will be 1 0. So here instead of this point we will have 1 0. Here the graph goes to infinity and the x-axis and the y-axis goes to 0. So here in the y-axis it will go to infinity and in the x-axis 0. So it will be like this. The graph will be like this. F inverse. We can write a domain of f inverse. Domain of f inverse is x-axis C 0 to 1. 0 less than x less than or equal to 1. And range of f inverse equal to, see range of f inverse is C y-axis y greater than or equal to 0. So this is a domain and range, or we can say range of f inverse is domain of f. Here domain of f is x greater than or equal to 0. So range of f inverse is y greater than or equal to 0. See the next question, y equal to 1 minus 1 by x, x greater than 0. So here domain is x greater than 0. So range will be y greater than 0. Range of f inverse will be y greater than 0. Okay, we can see here the points C. This is a 1 0. So in the f inverse, this point will be reversed and the point will be 0 1. Okay, see this will be the point. Okay, here the graph goes to x-axis infinity and y-axis to 1. So this is the point. If it goes to infinity 1, here it will goes to 1 infinity. Here see the graph f goes to 0 minus infinity and here it will go to minus infinity 0. Here minus infinity 0 is almost towards this and here goes to infinity 1. So in the f inverse 1 infinity is 1 to infinity. So the graph will be like this. Also, we can draw the line y equal to x. Y equal to x is here 1 pointer, and mark all other points. Y equal to x will be like this. See here, domain of f inverse is, look to the x-axis here. Here minus infinity to 1. So we can say domain of f inverse is equal to minus infinity less than x less than 1. It's just approaching to 1 and not taking the value 1. Okay, and range of f inverse is equal to, see the y-axis, greater than 0. So y greater than 0. Range is y greater than 0, or we can directly see here x greater than 0. So range of f inverse is y greater than 0. See the next question. Y equal to sin x minus pi by 2 less than or equal to x less than or equal to pi by 2. Here the points pi by 2 minus pi by 2 minus 1, 1 is given. Pi by 2, you know, pi equal to 3.14, therefore pi by 2 is 3.14 divided by 2. Okay. Here the point is pi by 2, 1. So in the f inverse, it will become 1 pi by 2. 1 we can mark almost here. Okay. Minus 1. So 1 pi by 2 somewhat here. So this will be 1 pi by 2. And here the point is minus pi by 2 minus 1. So it will become minus 1 minus pi by 2. So this will be the point. And 0, 0. So the graph will be like this. Here facing to x-axis. So here it will face to y-axis. Like that. Okay. And you can draw the line y equal to x also. The line will be minus 1 minus 1, almost like this. It will go in the same line. Okay, you can try to draw. See what is the domain and range. Here domain is equal to, domain of f inverse is equal to, see the x-axis, the points minus 1 to 1, that is minus 1 less than or equal to x less than or equal to 1, and the range of f inverse is equal to, domain of f is given minus pi by 2 less than or equal to x less than or equal to pi by 2. Therefore, range of f inverse will be minus pi by 2 less than or equal to y less than or equal to pi by 2. Or you can see the graph here. See the y-axis. Here minus pi by 2, here pi by 2. So minus pi by 2 less than or equal to y less than or equal to pi by 2. See the next question. Here y equal to tan x minus pi by 2 less than x less than pi by 2. Here towards x-axis it approaches pi by 2, and in the y-axis it approaches to infinity. So in the graph of f inverse, it will like in the x-axis it will approach to infinity, and in the y-axis to pi by 2. So we can mark pi by 2 here, minus pi by 2, pi by 2. So here the graph approaches to pi by 2 and infinity. So this point will be infinity to pi by 2 here. So it will be like here the points will be here, and here minus pi by 2 to infinity. So here infinity to minus pi by 2. So you can draw like this. So the graph will be like this, f inverse. Okay, and you can draw also the y equal to x line. See here a domain of f inverse. See the x-axis. This is the graph. I have no other color, sorry. Here go to minus infinity to infinity. So domain is minus infinity less than x less than infinity, and range of f inverse. Range of f inverse, see y-axis. Here minus pi by 2 to pi by 2. Minus pi by 2 less than y less than pi by 2. This you can directly see. Here domain of f is given. So this is the range of f inverse. Next question. Graph the function f of x is equal to root of 1 minus x square, 0 less than or equal to x less than or equal to 1. What symmetry does the graph have? Second one, show that f is its own inverse. Okay, we can draw the graph. When x is equal to 0, the point is 0, 1, and when x is equal to 1, the point is 1, 0. So see the graph, x-axis, y-axis. Here 1, here 1. So the points are 1, 0 and 0, 1. So the graph will be part of a circle. This is y equal to root of 1 minus x square, 0 less than or equal to x less than or equal to 1. What symmetry does the graph have? We can say this is symmetric about the line y equal to x. Show that f is its own inverse. We can find the inverse of this graph. Here y equal to root of 1 minus x square. To find inverse, first step is find x in terms of y. See, squaring we get y square is equal to 1 minus x square. That is x square is equal to 1 minus y square, or x is equal to root of 1 minus y square. Therefore, we can say f inverse of x. If this is the function f of x, then f inverse of x is equal to root of 1 minus x square. So, f has its own inverse. Or if we try to draw the graph of f inverse, we see here the point is 1, 0. So, it will become 0, 1 here. And here the point is 0, 1. And it will become by reversing 1, 0 here. So, the same f inverse. Next question, graph the function f of x is equal to 1 by x. What symmetry does the graph have? Show that f is its own inverse. So we can try to draw the graph. X-axis, y-axis. Here when x is, just to try, when x approaches to 0, graph y approaches to infinity. And when x approaches to infinity, graph approaches to 0. You know the graph of y equal to 1 by x. Like this. And in this axis also, this is the same. Okay, so here also we can say the graph is symmetric about the line y equal to x, and also f inverse you can find y equal to 1 by x. Then we can say x is equal to 1 by y, or f inverse of x is equal to 1 by x. Same inverse. See here, if the point is here approaching to in the x-axis to infinity and y-axis to 0. So this will become in f inverse x-axis to 0 and y-axis to infinity. That is this point. Like that it will get just a change. Formula for inverse functions. Find f inverse in each case. First one, f of x is equal to x square plus 1, x greater than or equal to 0. See, first question, we can write y equal to x square plus 1. So to find inverse, first step is to find x in terms of y, or solve for x in terms of y. This way we will get x square is equal to y minus 1, or x is equal to root of y minus 1. Or we can write f inverse of x is equal to, just interchange x and y, that is root of x minus 1. So f inverse of x is equal to root of x minus 1. Here the domain is x greater than or equal to 0. See, next question, f of x is equal to x square, x less than or equal to 0. Y equal to x square, we can write x less than or equal to 0. So taking square root, we can write x is equal to minus root y. Here see, if x is equal to, x is less than or equal to 0, x is equal to minus 1, then y equal to minus 1 square equal to 1. So we have to map 1 to minus 1. If we simply write root y, then it will be like, if y equal to 1, it will be like just we will write y 1 only. We need minus 1. So we can write like this. Since x less than or equal to 0, we can write like this. Next step is interchange x and y. So f inverse of x we can write minus root x. See, third question, f of x is equal to x cube minus 1. So we can write x cube is equal to y minus 1. So x is equal to cube root of y minus 1. We can interchange x and y. So we can write f inverse of x is equal to cube root of x minus 1. This is nothing but x minus 1 the whole raised to 1 by 3. Next question, fourth one, y equal to x square minus 2x plus 1, x greater than or equal to 1. X square minus 2x plus 1. This is nothing but x minus 1 the whole square. So we can write x minus 1 is equal to root y, or x is equal to 1 plus root y. Or we can write f inverse by interchanging x and y. We can write f inverse of x is equal to 1 plus root x. See next question. F of x is equal to x plus 1 the whole square. We can write y equal to x plus 1 the whole square, x greater than or equal to minus 1. Then taking square root, we get root y is equal to x plus 1. That is, x is equal to root y minus 1. Or we can write f inverse of x is equal to root x minus 1. Last question. F of x is equal to x raised to 2 by 3, x greater than or equal to 0. Here to get x, we can just take the power raised to 3 by 2. So we get y raised to 3 by 2 is equal to x raised to 2 by 3 into 3 by 2, that is 1 x. So we can interchange x and y. So we get f inverse of x is equal to x raised to 3 by 2. Next question. Find f inverse and identify the domain and range of f inverse. As a check, show that f of f inverse of x is equal to f inverse of f of x is equal to x. We know that to check f and f inverse, we have to see f composite f inverse equal to identity and f inverse composite f equal to identity. Okay, first question, f of x is equal to x raised to 5. Here domain is not specified, so domain will be the real line. Okay, so we can write y equal to x raised to 5, or x is equal to y raised to 1 by 5, or we can write f inverse of x is equal to x raised to 1 by 5. Here we can take domain as all the real line. Here also we can take domain as the all real line. Okay, so domain and range of f inverse we can say real line. To x raised to 1 by 5, we can take any value from the real line. No problem. Okay. Now we can check f of f inverse of x and f inverse of f of x. F of f inverse of x is equal to f of f inverse of x is x raised to 1 by 5. Instead of f inverse of x, we have x raised to 1 by 5. Now f of x raised to 1 by 5. F of x, we have x raised to 5. So f of x raised to 1 by 5 is, instead of x, put x raised to 1 by 5. That is x raised to 1 by 5 the whole raised to 5, which is equal to x. So this is true. Next, f inverse of f of x is equal to f inverse of f of x is x raised to 5. F inverse of x is x raised to 1 by 5. So f inverse of x raised to 5 is, put x raised to 5 instead of x. That is x raised to 5 the whole raised to 1 by 5, which is equal to x. So f of f inverse of x is equal to x equal to f inverse of f of x. Next question, f of x is equal to x raised to 4, x greater than or equal to 0. Here the domain is x greater than or equal to 0. So we know domain of f is the range of f inverse. So range of f inverse will be y greater than or equal to 0. Okay, we can see. We can write y equal to x raised to 4. That is x is equal to y raised to 1 by 4. Or we can write f inverse of x is equal to x raised to 1 by 4. This is f inverse of x. Here domain of f inverse and range of f inverse. Range of f inverse is y greater than or equal to 0. Here the function is x raised to 1 by 4. Can we give negative values to the x? No. What is minus 1 raised to 1 by 4? This is complex values. So we can check, take domain of f inverse is equal to x greater than or equal to 0. Range is also y greater than or equal to 0. Next, we can check f of f inverse of x and f inverse of f of x. F of f inverse of x is f of f inverse of x, x raised to 1 by 4. So f of x raised to 1 by 4 is x raised to 1 by 4 the whole raised to 4, which is equal to x. Like that, f inverse of f of x is equal to f inverse of f of x is x raised to 4. F inverse of x is x raised to 1 by 4. Therefore, f inverse of x raised to 4 is x raised to 4 the whole raised to 1 by 4, which is equal to x. Next question, f of x is equal to x cube plus 1. Here domain is not specified, so we can take real line. In case of square and the power of 2, that is x raised to 4, x raised to 6, like that, we have to check for the domain and range, because we know minus 1 square is equal to 1 and 1 square equal to 1. Like that, minus 1 raised to 4 equal to 1 and 1 raised to 4 is equal to 1. So these are not one function if we take the negative values also. But in case of minus 1 raised to cube is minus 1, 1 cube is 1. So in case of a cube, we have no problem. Okay. Here y equal to x cube plus 1. That is y minus 1 equal to x cube. So x is equal to y minus 1 the whole raised to 1 by 3. Or we can write f inverse of x is equal to x minus 1 the whole raised to 1 by 3. Here we can take domain and range of f inverse as the whole real line. We can take any values in the real line, no problem. It will not affect our 1 functions or anything. We are specifying the domain because inverse exists only for 1 functions. So while considering 1-to-1 functions, domain is important. Next, f of f inverse of x equal to f of f inverse of x is x minus 1 the whole raised to 1 by 3 equal to f of x is x cube plus 1. So x minus 1 the whole raised to 1 by 3 cube plus 1, which is equal to x minus 1 plus 1, which is equal to x. Like that, f inverse of f of x is equal to f inverse of f of x is x cube plus 1. F inverse of x is x minus 1 the whole raised to 1 by 3. Instead of x, x cube plus 1. X cube plus 1 minus 1 the whole raised to 1 by 3, which is equal to 1 minus 1 is 0. X cube raised to 1 by 3, which is equal to x. So f composite f inverse and f inverse composite f is equal to identity function. Next question, f of x is equal to 1 by 2x minus 7 by 2. Here also domain and range, no problem. This is nothing but a straight line with a slope 1 by 2 and a y-intercept minus 7 by 2. So we can write y equal to 1 by 2x minus 7 by 2. This is equal to x minus 7 by 2. So we can write 2y equal to x minus 7. Or x is equal to 2y plus 7. Or we can write f inverse of x is equal to interchange x and y, that is 2x plus 7. And we can say domain and range of f inverse is equal to, this is also a straight line. So we can take all negative values and positive values, real line. Now f of f inverse of x is equal to f of f inverse of x is 2x plus 7. This is equal to f of x is 1 by 2x minus 7 by 2. That is 1 by 2 into, instead of x, 2x plus 7. 2x plus 7 minus 7 by 2. This is equal to 2x plus 7 minus 7 by 2. Same denominator here. 7 minus 7 is 0. That is 2x by 2. That is x equal to x. Next, f inverse of f of x is equal to f inverse of 1 by 2x minus 7 by 2. That is x minus 7 by 2. F inverse of x is 2x plus 7. So f inverse of x minus 7 by 2 is 2 into x minus 7 by 2 plus 7. This is 2 get cancelled. X minus 7 plus 7, which is equal to x. Next question. f of x is equal to 1 by x square. Here the terms of x square is involved, so we have to check for the domain. So in case of x square, domain is x greater than or equal to 0 to be 1 by. Here 1 by x square, so cannot be 0 also. So the domain is x greater than 0. This is already given in the question itself, okay? Don't worry. So we can write y equal to 1 by x square. So x square is equal to 1 by y. So taking square root, we get x is equal to square root of 1 by y. But for square root of 1, we are taking only positive value, 1 only. So we can write 1 by root y. Otherwise, it will not be a 1 function, okay? So f inverse of x is equal to 1 by root x. Here the domain is x greater than 0. Domain is x greater than 0. If x is equal to 0, this function is not defined. And we know for the function root x, we are taking the domain always positive values. Here range of f inverse also y greater than 0. Domain of f is given x greater than 0. Domain of f is the range of f inverse. So this is range of f inverse. Now we can check f of f inverse of x equal to f of f inverse of x is 1 by root x. This is equal to f of x is 1 by x square. So f of 1 by root x is 1 by root x square, that is 1 by x. This is equal to 1 into x by 1, that is x. And f inverse of f of x equal to f inverse of 1 by x square. This is equal to f inverse of x is 1 by root x. So 1 by root of 1 by x square, that is 1 by x, which is equal to x. So this is all about inverse function. How to find inverse function, how to graph inverse function, how to check two functions are inverse pair. See you in the next video. Till then, bye bye.